Hi, this is Rich Trott of the UCSF Library and Center for Knowledge Management, and this is Mobile Maps That Aren't Terrible, Part 5. We're going to talk about some processes that will streamline, improve, simplify the processes that we've already talked about for creating tiled overlays for your maps, and here is the list of things that we will touch on. One of the improved processes will involve more Photoshop fun. More accurately, it will involve almost any image editor fun. You don't actually have to use Photoshop, of course. The pros to this new process are that it bypasses the painful, to me anyway, Photoshop image warping step that I described in one of the previous videos. This is where your map may not be done to scale, but you want it to line up with Google Maps anyway, so you have to warp the edges and other places perhaps to get streets to line up and so on and so forth. That step hopefully no longer necessary. It also allows us to bypass the lengthy map tiler step. Lengthy is an exaggeration here. Map tiler is actually awfully user-friendly as these things go, but I think it's a little more robust to use the GDAL command line stuff. And I think you can iterate more quickly with that stuff, and I think that means you can get to the desired result more quickly. There is a con, it's a minor one. You can't just do this Photoshop stuff, you also have to do the lat long stuff I'm going to describe and the GDAL stuff I'm going to describe, but all of this is pretty easy and has some substantial benefits, I believe. So we're going to open up Photoshop and we're going to get the pixel coordinates of key points on the edge of our overlay. Here we are in Photoshop with a map of the UCSF Mount Zion campus, an image representing that map. And you'll see over here off to the right, it might be hard to see in the video, but I have the info window open. So on the Mac I went to the window menu and selected info. And one of the things the info window tells me is what the x and y coordinates of the cursor are at any given moment. So right now I'm on the eastern edge of the map on Sutter Street, and I can see that the x coordinate is 3691 and the y coordinate is 947. For reasons that might become obvious, when dealing with the eastern or western edge of the map, we care about the y coordinate, and when dealing with the north and south edge of the map, we care about the x coordinate. So I'm going to put down Sutter, east, and the y coordinate, which is 947 on my sticky note here. Sutter, east, and I already forgot what I said it was. It was 947. Alright, let's do that. That's 947. So now I'm going to go around the edge of the map and I'm going to get the coordinates for anything that needs to line up with something in Google Maps. So in this case, it's pretty much just going to be streets. So here's the eastern edge of Post Street. That is at a y coordinate of 2066. So Post East is 2066. Here is what my sticky note looks like when it's completed. It has x and y coordinates as appropriate for all of the places where streets hit the edge of the map. You could also do this as the middle of intersections, etc., etc. So you might want to experiment, and of course it helps to have a very, very high resolution image when you're doing this stuff. The next thing we need is we need to determine the latitude and longitude of the same points that we just got the x and y coordinates for. There's more than one tool out there. I use the tool available at itouchmap.com. You'll get a lot of advertisements, but that's okay. It works. That's mostly what I care about. So I'm going to zoom in on the Mount Zion campus. There we go. Okay, so let's pull up the sticky note, and it also helps to have the image open in another window. Okay, so for example, here we have the western part of the map where Post Street exits the frame, and so Post on the western edge has a y coordinate in the image of 2661. So we want to get approximately the same place on the map, which I'm thinking is zoom in a little bit here. Post right just west of Broderick. So here we go. Post just west of Broderick, like right about there maybe. And it's going to give me the latitude and longitude. Okay, so I'm now going to go do that for the rest of the numbers. Here I'm going to get the latitude, longitude coordinate for Scott and Bush. One thing I've done is I've zoomed way in to ensure accuracy. Like that is not quite the middle of the intersection, but there we go. That's the middle of the intersection. Another thing I realized I should point out is that here I am in Photoshop. I'm going to get the middle of the intersection of Divisadero and Geary. Since this isn't on the edge of a map, I care about the X and the Y in this case, and I will care about the latitude and the longitude. Another thing to know is that the minimum number of these points that you should collect is 3. The more the better, of course, but 3 is the minimum to get this to work. Incidentally, if you use the Overlay Tiler web application that I mentioned in a previous video, it uses exactly 3 coordinates. So there you go. As you can see here, I have the coordinates for 3 points on the map, and I have the dimensions of the overlay. And let's see what's next. GDAL command line tools. So we're going to use GDAL translate to set coordinates for the overlay. Let's start with that. So here's my terminal window. Now you'll need to have installed MapTiler or the GDAL framework. Let's go ahead and see that I have GDAL. Okay, great. So I have 2 versions of the framework installed. Let's see which one will be used if I call it from the command line. It's the 1.8 version. Super. So the way this works is you need to type GDAL translate -GCP, which probably stands for something like geo coordinate point or something. Anyway, let's pull up our numbers here. We'll want the X pixel for the point we're specifying. In this case, we're specifying 3 points. Again, the more the better, but you must do at least 3. We'll then want the Y pixel, so 0, 15, 34. And then you'll want to reverse the latitude and longitude from the conventional way, because probably they correspond with the X and Y pixels. So in order to make this work, okay, so there we go. And then I'm going to do that 3 more times, and I won't make you sit through my painful typing. Okay, so we have our command line here, GDAL underbar translate space -GCP, and then 4 numbers, and then another -GCP, and another 4 numbers, and another -GCP, and another 4 numbers. Finally, you want to specify the input file and then an output directory. Or you don't want to specify an output directory, you want to specify an output file. There we go. So now the out.png that I specified as my last command line option has the image with a bunch of metadata about these points. Now, a note before we continue. We're going to now use GDAL to tiles.py. If you do not want the little border artifact that bothered me so much in one of the previous videos, you will have to include the small hack to GDAL to tiles.py that I describe in one of the previous videos. Additionally, GDAL to tiles.py still puts the tiles in a format that is not compatible with Google Maps version 3. We need to run the movetiles.sh script that I also described in a previous video to move the tiles to the correct location. Let's run GDAL to tiles.py -r anti-alias, which invokes the hack that we just mentioned, and then -s EPSG:4326. I don't really understand the difference between the various, I guess they're projections that are used. EPSG:4326 versus the W whatever that we used previously, but there you have it. And then we want to use as our input the PNG that was the output of the last command. And then let's specify a directory. We'll call it out. It will create it if it doesn't exist, where it will put the tiles. And it's going to generate the base tiles, and then it will generate all the other tiles. And as you can see, it's moving along pretty swiftly. We got about 30% done on the base tiles. And I will pause this for about 15 seconds to let this finish. Okay, it just finished. So we still have to go into the out directory. We'll see that it creates a few of the extraneous resources that we've talked about in previous videos. But it did generate tiles for zoom levels 16 through 20. That's good. Let's run the move tiles script, the aforementioned move tiles script. That shouldn't take too long. There we go. That's done. And now let's talk about ImageOptim, which is an image optimizer program. It makes all that PNGNQ and PNG crush stuff that we did in previous videos easy, and it works on the files in place, which means that all the post cleanup, lengthy command line find dot dash name blah 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 blah, none of that's needed anymore. Just go to imageoptim.com, download the app, and fire it up. Here you see the application's main window, and all you need to do is take your output directory and just drag and drop. It will find all the PNG files in it, and it will begin to optimize them. You can choose to optimize it again and again and again, seeing how much benefit you get through each iteration. I tend to just optimize once and be satisfied with that. Now this step might take a while, so I will pause the recording here, although I will wait for the first magical green indicator that one file is done. It's doing 6 files right now. There's a green indicator. Okay, probably the recording software is eating up all of the CPU or RAM or whatever, so perhaps when I pause it, it will go a little faster. Okay, great, it's all done. So now let's copy all the tile directories to the right place in our web server. Let's see, in my tiles directory. Oh, you want to copy -R, of course. Now let's pull up the map and see what it looks like. If I click on Mount Zion, let's see. Well, that looks pretty good. Let's see how the edges look. Yeah, the edges look pretty good. Same color. The streets line up more or less. Let's check down here. Oh, that one looks really good. This is the edge of the map. You can hardly tell except for the funky shaped street right there. So this is good. And then, of course, you know, the tiles load quickly as we zoom in. All the details there, etc., etc. So there you go. Thanks for watching.